Hello, this is Professor Eckhouse, and I'm going to talk to you today about section 2.2, which is evaluating, simplifying, and also translating algebraic expressions. I think I forgot that one word there. And before I go on, though, I wanted to point out that we have these links, if you need them, for each of the three different parts of section 2.2. It's basically separated into like pages that has the different topics within 2.2. Okay, so it's separated into evaluating, simplifying, and translating. And then there's a summary that has all of the key concepts, vocabulary, equations, things like that. So make good use of that. There's also a try it problem after every example in this section and a video. So make sure you're using those, especially if you're confused by any of this. All right, so evaluating an expression. So remember, an expression does not have an equal sign. There's no equal sign, right? It's just an expression, a bunch of terms with addition and subtraction between them. All right, so evaluate means to substitute the given number for the variables in the expression. So you're given what x or whatever it is equals, and you plug it in for every time you see that variable, and then you simplify it using order of operation. Make sure you use parentheses around the number you're substituting when you get to more complicated things. So I'll show you a simple one. Let's just say we're asked to evaluate x plus 5 when, now notice there's no equal sign. So we're not solving anything. There's no equal sign. We're just evaluating this expression when, let's say when x equals 2. Okay, so if we were solving, we would be solving for x and finding what it is. But instead, we are given x, which is the opposite of that. Okay, so make sure you understand the difference between evaluate and solve. All right, so we're evaluating. That means we are going to plug this 2 in where we see an x in the equation. Okay, so let's do that. So I'm going to say, instead of an x, I'm going to put that 2 in plus 5. And I get 7, all right? The next, I'll do it again. Let's say, what if x equals 20? Okay, so we're putting 20 in for the x, all right? So we're gonna say 20 plus 5 equals 25. Okay, so we're evaluating for different values of x. And that's part of the focus of this section. So pause the video and give these two a try. All right, so we've got 9x minus 2 when x equals 5. Okay, so we're going to, and this is an example of having to use parentheses. So I'm going to say there's an x right there, and I want to plug in this 5 in this right here, where the x was. Okay, so I'm going to put 5 in right there, and then I'm going to go back and say minus 2. So 9 times x is 5, minus 2. So I get 45 minus 2 is 43. All right, so that's the first one. Let's do number 2. So again, we've got 9x minus 2, and we're going to say 9 times whatever that is minus 2. Well, this time x equals 1. Okay, so we're going to put this 1 in for the x, which is right here. All right, so I'm going to put the 1 in. So 9 times 1 minus 2. So I get 9 minus 2, always do multiplication first, equals 7. All right, example 2. Evaluate x squared when x equals 10. So pause the video and give that a try. All right, so I'm going to take this 10 and I'm going to plug it in where the x is. So that is going to become 10 squared. So 10 squared is 10 times 10, which is 100. So this is an example of using parentheses. And anytime you have an exponent, I would use parentheses. All right, let's go on to example 3. Evaluate 2 to the x when x equals 5. So a little bit different. This time this is an exponential equation. 2 to the x when x equals 5. So that means we're going to take this 5 and we're going to put it right there where the x is. Okay, so we've got 2 to the 5 equals 2 times 2 times 2 times 2 times 2. You can use a calculator. It's 32. Okay, so evaluate means to continue simplifying until you get a number. All right, example 4. All right, so this one's just a little bit more complicated. Every single time we see an x, I'm going to use parentheses and a 4. Okay, so I'm going to say 2 parenthesis squared plus 3 parenthesis plus 8. So notice every time I had an x, I just put a blank parenthesis. That's one way you can do it when you first start doing this so you don't mess it up. Okay, so that 4, I'm going to use orange, goes in each of these. All right, so now order of operations is important. That's why we talked about it first. So I've got 2 times, exponents happen before multiplication. So 4 squared is 16. Okay, so 2 times, I'm going to use parentheses, 2 times 16, plus 3 times 4 is 12, plus 8. All right, 2 times 16 is 32, plus 12, plus 8. I'm just going to go left to right. And 32 plus 12 plus 8, I can just put that whole thing in your calculator if you want to, and you should get 52. And a faster way to do it, because it's all addition, you can actually change the order of it, because remember, addition is commutative. So I, in my head, did this. I said 8 plus 12 plus 32, because I know 8 plus 12 is 20. And that is really easy to add to 32 in my head. So that's how I did that. If it had any subtraction, I could not change the order. Okay, so be careful. If it's addition, you can. All right, example 5. Example 5 is asking us to evaluate. So pause the video and give that one a try. All right, so we have an x, and this is our x. And we have a y, and this is our y. So be careful when you do this, okay? So we've got 3 times the 10 is the x, plus 4 times the 2 is the y, minus 6. Now use order of operation, multiplication first. 3 times 10 is 30, plus 4 times 2 is 8, minus 6. All right, now there's a minus. We have to go left to right. Okay, so we do 30 plus 8 minus 6. 30 plus 8 is 38, then minus 6, and that's 32. All right. So next we're going to talk about terms, coefficients, and like terms. All right, so just so you didn't have to deal with my bad handwriting, I went ahead and put all of the definitions here, but we've got constant. A constant does not vary, it does not change. A variable, well, the base of the word is vary, so it does vary. It changes. It's generally a placeholder for something that can change, okay? Coefficient. A coefficient is the number in front of a variable. So for example, 3x, the coefficient is the 3. 7y squared, the coefficient is the 7. All right, a term, a single term, a single number or variables and numbers connected by multiplication. So those two things I just wrote down up there, 3x and 7y squared, those are terms. All right, terms are generally separated by plus and minus. Like terms are terms that are either constants or have the same variables with the same exponents. Okay, so like terms would be like 2x and 12x, or it would be 5y squared and 9y squared. Okay, they've got the same variable with the same exponent. The coefficient can be different, and what we do is add those or subtract them. Okay, as long as they have the same variable. They're called like terms, and we can combine those. All right, an algebraic expression is a collection of constants and variables joined together by algebraic operations. So a collection of constants and variables, basically that means a collection of terms. All right, an equation is a mathematical statement that two expressions are equal, is an equal sign, equation. Okay, I want to make sure that really stands out, so I did it in blue. We're not doing this yet, but make sure you understand the difference between an expression and an equation. All right, so here is an equation, and we're not quite doing this yet, but I want to make sure you understand the difference. There's the equation, the whole thing, with the equal sign in the middle. Okay, on each side there is an expression. The 3 right here is a coefficient, and the x is the variable. The 6 is the constant. The 12 is a constant. It's by itself, so it's called an expression. Okay? So be sure and ask in class if you don't understand any of that. All right, example 6. Try this one without me, so pause the video and see what you can do. Identify the like terms. All right, so I'm going to do like terms in the same color, right? So I've got y cubed. I want to find like terms to y cubed. Well, here's a 4y cubed, and there's nothing else. All right, now we've got 7x squared. That doesn't show up very well, does it? So let's do green, I guess. All right, so 7x squared, and there's a 5x squared. So those are like terms. Let's try pink. And then we've got 14, that's a constant. So I'm looking for any other constants, that's also a constant. 9x is gonna just kind of be off by itself, okay? It doesn't have anything with it. So there's no other x terms there. There's an x squared, 2x squareds, but those are not like terms because this is an x. All right, next one. 4x squared is here. I meant to change to that. 4x squared, and I see a 5x squared. All right, notice now these are separated by plus signs. This is an expression. The one with commas, that was just a list of terms. This is an expression. All right, so now we've got 2x. What's a like term to 2x? Well, we've got 6x, and we've got 40x. And then the last one is this 8xy. It doesn't have anything like it. Okay. So before we go on, I just wanted to talk about some things here, just to make sure you understand. Is there a way to write this more efficiently? Yes. So that is, we've got 1, 2, 3, 4, 5 x's. So that means it's 5x. 5x. What about this right here? Well, we've got them separated, so we've got a 3x and a 2x, and they're added together, but it's really just like it is up above. It's just 5x's. So really this still equals 5x. So notice what we did here. Well, all we did was we just added the 2 together. Okay, so I could have divided it like this, right? 4x and 1x, and it would still be 5x. All right, so let's move on. Write this the long way to understand how to simplify it. So maybe you already understand and you can just watch me, or you can skip this. But 3x would be x plus x plus x. 2y would be y plus y. And then another 4x would be x plus x plus x plus x. I'm never going to ask you to do this again. It's really long, but I just want you to see what's going on here. All right, so notice that this 3x and this 4x, they are like terms. And these x's can all combine together to be 1, 2, 3, 4, 5, 6, 7, 7x. We could take these two and add the 3 and the 4 to get 7x. Same thing with the y. There's a plus here. We've got a 2y and a y, so we get 3y's. Same thing here. 2y plus, and when there's nothing in front of it, it's a 1. 2y plus 1y is 3y. Okay? All right, so combining like terms. Identify the like terms like we just did. Rearrange so that the like terms are together, if you want to, and then add the coefficients. I like using colors and underlines, boxes, and circles, and that way I don't have to write it over again. But you can rewrite it if you would like. I don't always do that, to be honest. All right, so simplify this expression and also find the terms and the coefficients. So first let's find the terms. So here is a term, 3x, here's a term, here's a term, and here's a term. All right, so those are the terms. The coefficients, just so you know what everything is, the 3 is a coefficient, the 7 is a constant, so it's not a coefficient. The 4 is a coefficient. The 5 is a constant, so it's not a coefficient. Okay. All right, so let's simplify this by combining like terms. So first let's find the like terms. We've got 3x and 4x. What they want us to do is rewrite it in so that the ones that are similar are together. All right, so 3x and 4x are side by side. You don't have to do that if you don't want to, especially if you're using colors or underlining things, circling things, boxing things so that they stand out as different from one another. Another thing I do is as I combine them, I cross them out when I have really long expressions. All right, so then I've got plus 7 plus 5. So now I'm going to combine these two to get 7x, and I'm going to combine these two to get 12. 7x plus 12. Okay, so let's compare and contrast this really quick. I want you to think about the similarities or differences between 3x and x cubed. So pause the video for just a moment and think about that. What is the difference or similarity or whatever, compare and contrast 3x and x cubed? All right, so 3x means x plus x plus x. X cubed means x times x times x. So it's repeated. That's the similarity, but that's where it ends. Because this is repeated addition, and this is repeated multiplication. Okay, repeated multiplication. Okay, so make sure you've got that clear in your head. Pause it, think about it, whatever you need to do, but make sure you really understand the difference between something like 3x compared to x cubed, 2x compared to x squared. All right, example 8. Let's pause the video and simplify this, name the like terms and name the coefficients. All right, so let's find the like terms. So the like terms are 8x and 4x. And then 7x squared and 1x squared. So remember, when it has no number in front, it's just a 1. The coefficients are, in this case, 8, in this case, 7, in this case, 1, and in this case, 4. Those are the coefficients. All right, so I'm going to say 7x squared plus x squared and plus 8x plus 4x. So my like terms are colored. Okay, 7x plus x means 7x plus 1x is 8x squared, right? Plus 8x plus 4x is 12x. Right, next one. Translate words to algebraic expressions. So we're going to see things like the sum of a and b. Okay, so that means a plus b. The difference of a and b, and that is going to mean a minus b. The product of a and b, and that's going to mean a times b. And the quotient of a and b, I've run out of colors, the quotient of a and b is a divided by b, or you can write a over b. All right, so write the following as algebraic expressions. These are important to know how to do, so please do pause the video now and see if you can just at least do them in your head. But I would write them down so you can check. Okay, so important to be able to do these. The difference of 16 and 5 times a number. A number I'm going to call x. Okay, so the difference of 16, 5 times a number means 5x. Okay, so 16 minus 5x. Right, the quotient of 12x and 7. Quotient, remember, means divide the first one by the second one. So 12x divided by 7, or 12x over 7, or 12x over 7. The product of 3 and y. I'll do this in a different colors. This is all starting to get a little smushed together. All right, so the product of 3 and y, product means times, right? So that's just going to be 3y. 8 subtracted from 15. So 8 is not a number. It's written in words, but that's okay. Subtracted from 15 minus 8. And 10 less means to subtract 10. Then the product of 2 and b, so 2b. So subtract 10 from 2b, 2b minus 10. All right, translate each word phrase into an algebraic expression. These are tricky, so give them a try without me and then come back and see what the answer is. All right, so 5 times the sum of m and n. The sum of m and n means m plus n in parentheses, basically. So 5 times the sum of m plus n. Okay, so that's the first one. The second one is the sum of 5 times m and n. All right, the sum of, that means to add these two things together, 5 times m. It doesn't say 5 times n, it says 5 times m. So 5 times m plus n. So you've got to be very careful with the way these are written, and so you can tell the difference between those two. All right. Few application problems. The height of a rectangular window is 6 inches less than the width. All right, so I'm just going to draw it. So the height of a rectangular is 6 inches less than the width. So W is going to represent the width of the window. Okay, so W is the width. So the height is 6 inches less than the width. So that's W minus 6. So the expression, the answer is, because it asks for just an expression, is just this right here, W minus 6. If it wanted an equation, you would do the whole thing, H equals W minus 6. So watch the vocabulary. All right, Blanca has dimes and quarters in her purse. The number of dimes is 2 less than 5 times the number of quarters. All right, so 2 less means minus 2. Subtract 2. 5 times the quarters, that means 5. It says Q is going to be quarters, 5Q. Write an expression for the number of dimes. Well, 2 less than 5Q, so 5Q minus 2. Okay, 5Q minus 2. All right, and that is it. Thank you for watching.